Hello, welcome back to my channel, and in this video we are going to solve this JEE advanced mathematic problem. This was asked in 2024, and let's look at the problem and try to come up with some strategy. How will you solve this problem when you come when you see this in an exam? So let's look at the information. This is the differential function on an interval 0 to infinity, which means you can differentiate it, which is gonna be important. And they given you a condition f is equal to 1. When you plug 1 in the function, you get 2, and they given you a limit that this involve this function that should be equal to 1, and they want you to identify what kind of this function is. This is very straightforward. Whenever you have a limit problem, you're going to plug in the limit in your question and see what kind of indeterminate form it make, and from figuring out what kind of indeterminate form you're going to apply your method. In this case when you plug it in, you're gonna get 0 by 0 or infinity by infinity. That means you can apply the L'Hopital rule, and you know this differential function. That's why they're giving you this is continuously differential function, so you can differentiate it in the interval 0 to infinity. And after you get then after you apply the L'Hopital rule, you're gonna get a differential equation. They given you one condition, and from there you can calculate the constant. And this is a very straightforward question. There's no out of the box thinking. You know all the steps you need to do to get to the answer. And one thing, just before even doing the problem, they given you what your function should be. X is equal to 1, that is equal to 2. One thing you can do is so f is equal to 1 is equal to 2. You can plug 1 in all the option and see if one of them if they all come to 2 or some of them come to 2, just to make sure. If some of the option can get rid of, it's easy. If you have time, you can do that. Maybe only one function make it 2, but in this case all of them actually become 2, because this is an advanced level problem. They're not going to give an easy such a easy problem. But whenever you have such kind of condition in your problem, you should be thinking about all these in your mind whenever you're solving problem. And some of the problem would be very easy if you are more aware of all the conditions they're given you, and you can apply all the strategies in your problem solving skill. So in this case, when you plug 1 in all these options, you're gonna get 2. So it's not that easy. You can answer based on that condition, but this is also a very easy question, very easy marks you can get from this. So let's solve this problem. So when you plug t is equal to x, what you're gonna get is 0 by 0, and you can apply L'Hopital rule. And one thing to be make sure, the variable here is t, not x. So make sure you understand that. Now we can apply the L'Hopital rule. Basically mean we can differentiate the numerator and the denominator with respect to t. Don't differentiate with respect to x. Yeah, so don't differentiate with respect to x, because t is the one that is standing to x axis, just a constant here, and this should be equal to 1. And now you have done this. If you're preparing for JEE, you have done this many times. Just differentiate this and you will get the answer here. T10 and f of x, this is the constant, you don't really care, and this is x to the power 10, and here you put t is equal to x. Okay, and you have this very good answer here. Now the denominator is very easy. It's 90 to the power 8. X is constant, so it's 0. And so here t is equal to x is equal to 1. You can now plug x in and get differential equation. And this is 9 to the x to the power 8. That should be equal to 1. Now what you can do is manipulate it to look like this is gonna be a linear differential equation, and you can manipulate it to look like a linear differential equation. One thing you can do is this is going to be 10 x f of x minus 10 2, and I'm just doing it fast, so but you can do it as you like it. So yeah, now I'm gonna try to write it in terms of the way I think it should be written, and then 10 to the next here, and here it should be, you can put minus 9 here, Now this is a linear differential equation. What you can do is divide by x square, so you get this linear differential equation, and this is not a separable polynomial. You can use, in this case, you can use integrating factor method, and we're gonna do that and solve this problem. What we're gonna do is use integrating factor method, and in this our equation here is f of x minus 10 to the power x, f of x is equal to minus 9 over x square. The integrating factor here is 10 to the power minus 10 to the power e to the power integration of minus 10 to divided by x dx. This is my integrating factor. This is very easy. This is very easy integration, and you can manipulate it, and this become x to the power 10, and you can multiply this on both side, and you can multiply this on both side, where we have this now I have this f of x minus 9 f of minus 12, and what I get now is, if you look at this, this is basically differential with respect to x of x to the power negative 10 f of x. This is, you can see, this is the whole point of integrating factor is, and now you can integrate on both side, and see, you get x to the power negative 10 f of x, and this is negative 11 x to the power 11 plus c. Now you have your function f of x is equal to, one thing I think I did this wrong, so you can yeah, this negative will go away when you integrate, and now you can, what you can do, f of 1 is equal to 2, you can plug f is equal to 1, which is 9 over 11 plus c is equal to 2, and this give you c is equal to 2 minus, so this gives you 13 by 11. So now we have our function, which is 9 divided by 11x plus 13 by 11 x to the power 10, and this is our solution. The answer is option B. So here I took more time, but you're gonna do it faster. So I hope you like this video. If you do, give it a thumbs up, and I will see you next time.